We are in section 7-4. And I know that I promised you no calculus, but now we're in section 7-4, so we may have to do some. Okay, let's say that I have x double prime plus x is equal to the cosine of t. And I have x of 0 is equal to 0, and x prime of 0 is equal to 0. Then I have, if I solve that, I'm going to have x of s is equal to sine s squared plus 1 quantity squared. And then I look at that and say, well, that's is equal to s over sine s plus 1 times 1 over s squared plus 1. And I could say, well, gee, isn't that the Laplace transform of cosine t times the Laplace transform of sine t? And of course it is. And then I say, well, but what happens if I take and look at the Laplace transform of cosine t times sine t? What do I do? Well, that's going to equal the Laplace transform of 1/2 the sine of 2t. And that's going to equal 1 over s squared plus 4 in times a half, because there's a half sitting there, which is not equal to s over s squared plus 1 squared. So that's kind of inconvenient. What are we doing? How come that's the case? Well, it is the case, so we're going to have to deal with it. Now, as it turns out, there exists a function, and that function is h of t, which is equal to integral 0 to t of f of tau g of tau minus t minus tau d tau. There's t's and there's t's, and there's Greek letter taus and Greek letter taus, and they're different. Okay, and if I have that thing and I take the Laplace transform of h of t, then that's going to be h of s. Isn't that nice? But it's also going to be f of s g of s. That f of s, that g of s. So that's the way it is. So now we're going to come and have a definition, because we can, so we can define things. And we're going to say that the convolution of two functions g star h of t is going to equal the integral 0 to t f of tau g of t minus tau d tau. So we're going to say the convolution of f and g, which has no definition except for the definition I'm giving you. It has no meaning in the rest of the world except on this particular day in this particular form. Okay, now we have theorem 2. Theorem, there's an e there, 2, and there's no e here. Oh well, doesn't matter. Okay, so we have f of s. What do I have if I take the derivative of f of s? Well, that's going to be the Laplace transform of minus t f of t. What if I take so that this is where we break away from no calculus. So I'm obviously doing calculus here. What if I take the Laplace transform of f of t divided by t? What am I going to get? Well, I'm going to get the integral tau to infinity of f of sigma d sigma. Okay, so that's kind of cool. And then we can look at the convolution guy too and say, well, if I take the inverse transform of f of s times g of s, that's going to be equal to f of t convoluted with g of t. And if I take the Laplace transform of f of t convoluted with g of t, I'm going to get the Laplace transform of f of t times the Laplace transform of g of t. Okay, I hope that's all the theory we have to deal with. No, it isn't. Okay, so we have another theorem. Theorem 3. If we look at the Laplace transform of f of t divided by t, and we see that that's equal to integral 0 to infinity f of sigma d sigma, then we can say, well, f of t is equal to the inverse transform of f of s, which is going to be equal to t inverse transform of the integral s to infinity f of sigma d sigma. And I'm pretty sure that this is a s here. Pretty sure that's the case. Okay, well, we're done talking about theory. Now we're into solving problems using the theory, which is always helpful to do if we can do that. So problem number 2, that doesn't look much like a 2. Problem number 2, I have f of t is equal to t, and g of t is equal to e to the what? At. And I want to know what f of t convoluted with g of t is. Okay, that's what I want to do. Okay, that's what I'm going to do. So if I look at the Laplace transform of f of t convoluted with g of t, what do I get? I get the Laplace transform of t times the Laplace transform of e to the at. And we notice that this guy is going to be number 5, and we notice that this guy is going to be number 7 on our Laplace transform table. So the Laplace transform of f of t convoluted with g of t is going to be 1 over s squared times 1 over s minus a. Okay, isn't that lovely? So we have to do something with that so we can do something. Well, anyway, we're going to have, and we'll do a partial fraction guy. So a over s, b over s squared, c over s minus a. Okay, and that's going to equal the Laplace transform of the convolution. All right, that's fine. We can do that. which is 1 over s squared s minus a. And this is going to be a s squared minus a, big A, little a, with an s. With an s? Yes, with an s. And then this guy is just going to be bs minus b, little a. And then this guy here is going to be plus c squared. And that's all going to be over s squared s minus 2. And then we look at the s squared term, and we see that we have a, which has to be 0. We look at the s term. What's happening here? This is cs squared. So we have a plus c is equal to 0. We look at the a term, minus the s term, a, little a, plus b is equal to 0. And then we look at the unit term, and we have minus b, little a is equal to 1. Okay? That being the case, we can figure out that b has to equal minus 1 over a. And if b is minus 1 over a, then a has to be minus 1 over a squared. And if a is minus 1 over a squared, then c has to be 1 over a squared. Okay? So now we have that 1 over s squared s minus a is going to be minus 1 over a squared divided by s minus 1 over a divided by s squared plus 1 over a squared divided by s minus a. We see that all those are in our Laplace transform table. We take the Laplace transform of both sides. So we're taking the Laplace transform of f convoluted g is what we're doing. Inverse Laplace transform I'm taking the inverse Laplace transform of the Laplace transform of f convoluted g. Okay, I'm getting minus 1 over a squared minus 1 over a t plus 1 over a squared e to the at. Alright, so what do I got? Well, I've got that t convoluted with e to the at is going to equal 1 over minus 1 over a squared minus 1 over at plus 1 over a squared e to the at, and that checks with back of book. There are other ways I could have done that. I just chose not to today. Okay, problem number 2. Problem number 4. We have f of t is equal to t squared. G of t is equal to cosine t. And we're going to look at the Laplace transform of f of t convoluted with g of t. And we're going to say, well, that's going to be the Laplace transform of t squared times the Laplace transform of cosine t. And we look at our Laplace transform tables and we say this is 6. And we say this is 10. Okay. And we say, well, then that's going to be equal to 2 over s cubed times s over s squared plus 2. Okay. Seems like s cubed 2 over s1. Okay, so it's going to be 2 over s squared plus 2. And we look at our table of Laplace transforms, we see that this is number 23. And so we have, that being the case, f of t convoluted with g of t is going to equal 2, that's that 2 there, t minus sine t, which checks with back of book. Okay, we're going to do number 6. Look at the Laplace transform of f convoluted with g, and that's going to be the Laplace transform of e to the at times the Laplace transform of e to the bt. Okay, so we're going to have 1 over s minus a times 1 over s minus b, which is going to be 1 over s minus a times s minus b. And we see that that's number 12. And we see that we're going to need an a minus b on top though. So we're going to have 1 over a minus b times a minus b divided by s minus a, s minus b. Okay, so that looks good. I'm going to do an inverse Laplace transform of that, and I'm going to get f convoluted with g of t, and I'm going to have 1 over a minus b e to the at minus e to the bt. Okay, so much for problem number 6. Problem number 8. And we're going to do problem number 8 slightly different. Okay, we have f of s is equal to 1 over s squared plus 4. Okay, we look at that and we look and see that that's number 22. And that's going to have something like 1 over 4, 1 minus cosine 2t as the inverse Laplace transform. So now we're going to say, okay, now that we know that that's the case, we're going to say, well, we're going to look at the Laplace transform of f convoluted with g, which we don't know what it is. And that's going to be the Laplace transform of f of t times the Laplace transform of g of t. Okay, and we're going to say, well, that's going to be 1 over s times 1 over s squared plus 4 is going to be the Laplace transform of f convoluted with g of t. Okay, and we look at that and we say, well, if I take the inverse Laplace transform, I'm going to get a 1. I'm going to say my f of t is a 1, and my g of t is a 1/2 sine 2t. Where'd the 1/2 come from? Oh, I know where the 1/2 came from because there's no 2 up here. I needed 2 up there, so I have to put 1/2 there. Okay. So f convoluted with g is equal to integral 0 to t f of t g of t minus tau d tau. Okay, so that's what I've got. So it's going to be integral 0 to t of 1, but then there's a 1/2, so I'm going to put a 1/2 there, sine of 2 t minus tau dt, d tau. Okay, so that's going to be minus 1/2 cosine 2 t minus tau divided by minus 2, because the t is not the independent variable, the tau is, so there's a minus sign there, so that's why it's minus 2. Evaluated at 0 and t. Okay, so I'm going to have 1/4 minus, well, when I put a t in there, I'm going to have t here. I'm going to have 0, that's going to be 1, so that's going to be 1/4. Minus, when I put a 0 in here, a 0 in there, I'm going to have cosine 2 tau. So it's going to be minus, 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 bunch of minuses, 1/4 cosine 2t, and that checks with back of book. Okay, wasn't that lovely? Now we're going to go to number 10. We have f of s is equal to 1/s squared plus k squared, and we see that that's going to be 1/s squared times 1/k over s squared plus k squared, and that that guy is going to be a t, and this guy is going to look like sine kt over k, all applied together. Okay, so that's what they're looking like. Or f of t, because this is really the Laplace transform of f of t is going to be t convoluted with sine kt over k. Okay, so that's what we got. So that means, being the case, f of t is going to be 1/k integral 0 to t of sine. We're going to go the other way. There's no reason we shouldn't. So we're going to go the other way on this guy. We're going to say that the first guy is the sine kt over k, and the second guy is just t. Okay, so sine kt times t minus tau d tau. So I've got a t sign and a minus tau sign sitting there. Alright, so I will rewrite that as t over k. The t is not an independent variable, so I can bring it out, just like the k is. Integral 0 to t sine kt d k tau, that's a tau, d tau. Oh, what a mess. T tau minus, that's the minus sign, 1 over k, integral 0 to t, tau, sine k tau, t tau. Okay. So I look in the back of the book for that particular integral and it doesn't give it to me. So I go to my Maple program to get that integral because I can. And I know what the sine of kt is, so that's not a problem. So this is going to equal to t over k minus cosine k tau divided by k evaluated at 0 and t. Now the t and 0 don't go over here, they go in that tau guy. Okay. Then we have minus bracket minus bracket another minus sine kt minus t cosine kt divided by k squared times, I ran out of room. Well, luckily I can salvage my room situation because I can just move this over here some. Okay. So we'll get rid of that bracket first and continue over there. This is times, this is a plus sign, plus t cosine kt k bracket 1 over k another bracket. Okay, so we're all set. Okay, so what do I have? I have minus t cosine k t plus t when this is 0 divided by k squared. And on the other side I have a plus sign. Minus minus makes a plus. The first guy is negative, so minus sine kt divided by k cubed plus t cosine kt divided by k squared. Okay. Now over here I have minus t cosine kt over k squared, and here I've got t cosine kt. So minus guy, plus guy, they go away, and all I have left over is t over k squared minus sine kt over k cubed. And if I rewrite that as t minus sine kt over k cubed, then I have what f of t is. And that checks with the back of the book. Now don't ask me how many times it took me to get there.